Okay, so this next one here, we're gonna say that we have a point, negative AB, so I put it in quadrant 2 here, negative A, positive B, and the terminal the terminal arm lies on the end of theta here. Okay, so that point here is the point that defines that angle, and that's going to be negative A comma B. We don't know how big this circle is, and we're asked to find we want the units. We want the point on the unit circle that has the same angle theta. So what I'm going to do then is I'm just going to assume that the unit circle is smaller. Now it doesn't really matter, but I'm just going to draw my unit circle here, and I want to find that point. And I know that length is 1. And I know the point on the unit circle really is just going to be sine and cos. Well, sine and cos can be defined like this. So we can find the point B as the cosine of angle theta, and the y is sine of angle theta. Well, the sine of angle theta is going to be, so the cosine of angle theta is going to be negative A over the radius. And this is going to be B over, let's make that A, B over the radius. And that's it. There's my point B. I could also think of this as I need to scale this down by a factor of that radius here. So it's going to be this ratio of this line to the red line. And essentially I'm just going to divide by a squared plus b squared, which is essentially what I've done here with those x and y coordinates. Okay, so the unit circle is also useful to define tangent. Okay, so we talked about tangent as slope, okay, slope of that line, and tangent line, the tangent ratio we can say as the vertical compared to the horizontal, which is slope. We could also say that sine divided by cos, because now we've defined this on the unit circle as this length is sine, this length is cos. We can also do it this way. We can say that the line from here, I'm just going to do it in a different color here, this line from here to here is 1. Okay, that's equal to 1. Well, if I want to know the tangent ratio is the vertical compared to the horizontal in the blue, but it's also the vertical compared to the horizontal in this bigger triangle. So the tangent ratio is going to be we'll call this y over 1. Yeah, that's right. This tangent, y over x. Well, what that means then, if the denominator is 1, really, we can just saying that the y value, this height, this length here, is equal to tan. And so tan shows up as a length in the unit circle. So not just slope, right? We understand it as slope, but it's also now a length. There's actually a length associated with it in the unit circle, and we can do geometry on this. Okay, and we can say that this squared plus this squared equals this line squared. This line happens to be called the secant line, which is the reciprocal of cos. I'm not going to prove it right now, but it's fairly easy to prove. In fact, we can easily prove it. We can say that this line divided by this line is cos. So we're going to say that this line divided by this line is secant, which is the reciprocal. So that must be secant over 1. So if we establish that's the case, then we can come up with lots of identities here. We can say that tan squared plus 1 squared equals secant squared. And we can start doing all this geometry with this unit circle, because now we're establishing length in this unit circle. The main one, though, we want to stick with is sine and cos. Make sure that sine is y, cos is x, and we understand those to be length in the unit circle. But all the other ratios actually happen to show up in this unit circle. So there it is again. There's my secant line. So 1 squared plus tan squared equals secant squared. Cos squared plus sine squared equals a radius 1 squared. There's also this ratio here. This is called the cotan line. Right? This line here, the length of that line is a cotan ratio. And this squared plus this squared equals this line squared, which happens to be the cosecant squared. So there's another identity there. And when we get into trig identities, we'll explore those even more. But You don't really need to know and remember this, but appreciate what it is. We can start talking about these ratios, sine and cos, as lengths in a diagram, which then allows us to do much more geometry. Okay, so that's very powerful that way. At the very least, though, we can use the unit circle as a unit rate to kind of scale things up and down. Okay, so that's like a more, that's another use of it, and it may be an easier use of it, but it's not the only use of it.